60. This is UNO summer session number 3. Today we're going to discuss integration containing trig functions. So the part of integration that we will discuss today be integration sine raised to the power of n x dx or cosine raised to the power of n x dx. And at this time n would be greater than 2, or n would be equal or greater than 2. Also, we will discuss this type of integral where n and m here are integers. So we will also discuss this type of integration and that type of integration, and also this type of product integration. So first thing is this type of integration, you know about it through practice. So if you practice, be good at it. So here we want to find the integral of sine raised to the power of 5x dx. So the only way we can do this is we can use these formulas. So we know that sine square x plus cosine square x is equal to 1. We're going to be using that a lot. Okay, at this time, if we say sine square x is equal to 1 minus cosine square x. So I guess all of you are familiar with this trig identity. At this point, we're going to say integral, okay, of, so we're going to say 1 minus cosine square of x. So we took sine square of x, and then this we raise it to the power of 2. That means we took actually about sine is the power of 4 of x, okay, times sine of x dx. But now we're going to say, let's say u is equal to sine of x. Then when we take the derivative of that, we're going to find that negative sine of x dx is equal to du. So that means sine of x dx, it's basically equals to negative du. So then now we substitute everything here in terms of u. So we're going to say integral of 1 minus squared all squared, okay, times negative u. So that would be equal to negative. Going to fold this squared u raised to the power du. Then that should give you, we do the integration of that to negative u negative plus 2 u raised to the power of 3 divided by 3 minus u raised to the power of 5 divided by 5 plus c constant. And then now we substitute everything in terms of cosine. So this is also this is similar to one we just discussed. At this point, I want to do this, so I'm going to say integral of cosine squared x cosine x dx. So if we use this uh, that sine square of x plus cosine square of is equal to 1, and then now we say cosine square of x, that would be equals to 1 minus sine square of x. And then now we do the substitution. So instead of cosine square of x, I'm going to square 1 minus sine square x. Okay, cosine of x dx. So let's say we have u equals to sine of x. So then du be equals to cosine of x dx. Then now we're going to substitute everything in terms of u. We have integral of we have 1 minus u squared du, and that should be equal to 1 to u minus u to the third 3 plus c. So that is problem solution of problem number 2. And then in terms of signs, that is going to be equals to that is going to be equals to sine x will be equal to sine x minus sine raised to the power of 3x divided by this divided by 3 plus c. That should be the final answer. Okay, we're going to use one of the trig identity here. So sine square of x, it's equals to 1 2 minus cosine 2x divided by 2. So we're going to use this trig identity. So, and then our integration would be very easy. Sine 2x over 2 dx. Then we're going to have x2 minus 1 over. So then that is cosine. When we integrate it, we get sine 2x plus c. Okay, so it's pertaining to problem number 3. Now we're going to discuss problem number 4. Want to find the integration of sine raised to the power of 5 5x, and then cosine raised to the power 1/2 x dx. So in this type of we're going to use some sort of substitution as well. The first thing we're going to know is that we want to say integration of sine raised to the power of x cosine raised to the power of 1/2 x times sine of x dx. We're going to translate everything in terms of cosine. So then we're going to use the identity. So this is going to be equal to 1 minus cosine squared x squared times sine 1/2 x times sine x dx. So, and then when we FOIL this, we're going to get 1 minus 2 sine squared x plus sine raised to the power of x. This is multiplied with cosine raised to the power 1/2 sine x dx. Okay. So, and then when we multiply this out, multiply this in, we're going to get integral of cosine cosine raised to the power 1/2 x minus 2 cosine raised to the power of 5 2 x plus cosine raised to the power of 9 over 2x dx times sine x, sine x dx. We switch the places here. So now we're going to use the u substitution. So we're going to say u is equal to cosine x, and then du be equals to negative sine x dx. That means everything here is going to be negated. So when using that u substitution, so our integral should be equals to negative on the outside of raised to the power 1/2 minus 2 u raised to the power 5 2 plus u raised to the power of 9 over 2 du. And then when we do the integration, we should get negative 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 raised to the power of 3 over 2 divided by 3 over 2 plus 2 times 2 7 u raised to the power of 7 over 2 um, plus um, plus, oh sorry, minus, it should be this one. So minus u raised to the power of 11 2 divided by 11 plus c. And then we can do the substitution. So here I'm going to have 2, 3 cosine 3 over 2x plus 7 sine of 7 over 2x minus 2 11 cosine of 11 2x plus c. So in problem number 5, we have here tangent. We want to integrate tangent cubic uh, of um, of x, and then we want to also this is multiplied by secant raised to the power of 4x. So in order to do that, we are going to use the following. Need to remember that that every time we have tangent like this, we have to remember that secant square x it's equals to 1 plus tangent square x. This is an identity that we need to remember every time we are doing this type of problem. So here we're going to say tangent square x times tangent x times secant raised to the power 4x dx. So if we use the identity, then we say integral of so it's going to be integral of tangent x. So when we do this one here is going to be equals to secant square x minus 1 times secant cube x secant x dx. Okay, so we do the u substitution. So then when we do u substitution, so u is going to be equals to secant x. So then du to secant x tangent x. So here what I'm going to do, I'm going to multiply these out. So I'm going to have secant raised to the power of 5x minus secant raised to the power of 3x. So then this one and this one here, we have tangent x secant x dx. So when we do the substitution, we're going to have raised to the power of 5 minus u raised to the power of 3 du and then when we do the integration, we should get u raised to the power of 6 over 6 minus u raised to the power of 4 plus c. And then just with substitution, we can get uh, the answer. Right now, we are going to use similar identity that secant the square of x is equal to tangent square x plus 1. So at this point, we're going to uh, say that integral of tangent square of x 1 plus tangent square of x raised to the power of 2, and then here I have secant square of x dx. So then when we FOIL that one, the tangent square x 1 plus 2 tangent square x plus tangent raised to the power of 4x secant square x dx. So if we use the u substitution that u is equal to tangent x, then du is going to be equal to secant square x dx. Then we do the substitution here. So we substitute, going to have u raised to the power of 2 raised to the power of 2 plus 2u raised to the power of 4 plus u raised to the power of 6 du. So then using the integration, so I have raised to the power of 3 over 3 plus 2 u raised to the power of 5 plus u raised to the power of 7 plus c. So that, and then we substitute for u equals to 10x. Okay. All right. So in this problem, we're going to use the identity that says sine 3x sine of 2x. So that would be equals to cosine x over 2 minus cosine 5x over 2. So we're going to use this instead of this. Then we will have integral of cosine x 2 minus cosine 5x 2 dx, and that should give you sine x 2 minus 1 over 10 sine 5x plus c. That's the end. All right.